Okay, here we are in part 2 with the output shafts for the two engines. The GT shaft you can see here on the left and the GS shaft you can see on the right. Again, we had some issues here which needed to be addressed for these two particular shafts to allow them to fit in. Again, we had the situation where the GT shaft carries a rebate for that oil seal to allow the oil to seal and flow in the middle of the shaft. And again, the GS shaft has that feature, but it doesn't have the rebate that the seal can fit. So again, you have to machine the end of the shaft for the seal to be able to be pressed in, and they all press in flush. So that's definitely a requirement. Another thing too was the end of the shaft where the first gear sits on the GT has a large hole that the oil flows out to keep that bushing lubricated. The GS shafts have a hole but it's smaller, and most of the GS shafts show significant slop in the bushing, which means that the smaller hole is obviously not getting enough oil to the gear and causing the bushing to prematurely wear. You need to open that hole to the dimensions of the GT shaft so you maintain that correct oil flow there. On the end here there is a collar you can see. The GS shaft has that collar, but it sticks out a little further, so the bearing is further away in terms of dimensions from left to right, which means the shaft cannot fit in the gearbox housing. You can alter this two ways. You can cut that flange back approximately 1.6 millimeters to allow the bearing to go further up, or you can machine the inner side of the inner race to allow the bearing to slide further up. I chose to do the bearing because it was easier, and there's plenty of material on the inside of the bearing race, and the shaft is hard and I did not want to cut through the hardened case of the flange. Obviously you can see the differences here. The GT shaft is shorter with the older wide spline. The GS shaft is the newer spline they still use today, and it's longer. This is very beneficial because it allows you to run an X-ring chain with a modern sprocket, and then you can space it to suit. It just clears the cases, whereas the GT one has a problem with lack of room to space because the shaft is so short. Basically that is what is the coverage there. Of course the big benefit here is that the GS shaft has the better ratios. It doesn't have that problem the GT shafts have where the first gear is too low, the second gear is too high, and it also doesn't suffer from that clunk between first and second the GTs are known for. Retrofitting this is about probably maybe 3-4 hours work using a lathe in your home shop if you have one. A good machinist can do it, but it's time consuming because you're cutting hardened steel and therefore you need the appropriate tools to do it. No hacksaw, no file, nothing will work on this. It has to be done in a professional machine shop. That about covers it.